Alright, hello everyone, and I hope that you're doing well. I'm not going to have the camera on today because I always feel like I'm just dragging it out of my way. So we'll see how this works. So we've made it to Module 3, and Module 3 covers the algebra of functions and average rate of change, and of course average rate of change is very similar to slope. So we're going to first look at how do I solve a linear equation in one variable. So we have the following steps. We can simplify both sides of the equation. You can use the distributive property. You can combine like terms. You can possibly get rid of those fractions and decimals by multiplying by the least common denominator. And we'll see some examples of that. We can use the addition property of equality to collect the variable terms on one side of the equation and the constant terms, or the terms without a variable, on the other side. We can use the multiplication property of equality to make the coefficient on the variable term equal to 1. We can check the potential solution in the original equation, and we can write the solution set. Okay, so let's begin with this one. So I need to get my constants, or my whole number terms, over to the other side. This is a positive 16, so I can accomplish that by subtracting 16 from both sides. I always make my little line underneath, and I think, well, I haven't done anything to that negative 3x, so I'm just going to write it down, and 25 minus 16 should leave me with 9. Okay, then I'm going to divide by my negative 3 on both sides. So x is going to equal negative 3. And I'm done. Now let's look at this one. This one has some of that distributive property that I need to apply first. So I'm going to ensure that I multiply. There's nothing done to the x, so it's going to come down. Positive 4x times positive x, that becomes positive 4x. Positive 4 times negative 5, that's 20, but it's negative 20, because a positive times a negative is negative. Now on this side, 4 times x is 4x. Positive 4 times negative 2 is negative 8. Okay, so now I can go to my part of combining like terms. That was one of our suggestions. 4x's plus another x makes 5x's, and I'm just going to bring everything else down that I haven't worked with yet. Now I want x's on one side and my whole numbers on the other. So I'm going to add 20 over to get to where the whole numbers are no longer on the left-hand side. So I'm going to have 5x is equal to 4x. Negative 8 plus 20 is positive 12. Now I need to subtract my 4x over, subtract my 4x over. If I've got 5x's and I take 4x's away, I've only got 1x left. So my answer is x is equal to 12. Okay. Now let's look at this another one here. So this is again one where I need to distribute. 2x, nothing's been done to. Negative 3 times positive 2 is negative 6x. Negative 3 times positive 2 is negative 6. Is equal to 1. Negative 5 times positive 4 is negative 20x. Negative 5 times positive 3 is negative 15. Now I can collect my like terms. 2x minus 6x is negative 4x minus 6, which is equal to 1. Well, wait a minute. We can combine those, can't we? Now, a positive 1 minus 15 is negative 14 minus 20x. Okay, now I want to get my whole numbers over, so I'm going to add 6 to that negative 14. I'm going to leave my negative 4. X is equal to negative 14 plus 6 is negative 8 minus 20x. I can add my 20x to both sides. Whoops, didn't mean to draw through that. Hopefully y'all can still see that. It's going to leave me with positive 16 and negative 8. So I would need to divide by 16 on both sides. X is going to equal 8 will go into both of these, so I can simplify that to negative 1/2. Okay. Now this one is one where I kindly want to try to get rid of those decimals as best as I can. And if I multiply this entire thing by 10, I can do just that. Well, it would make, hold on a minute, I need to do just a little bit to this side first. I need to distribute that 0.2. So 5 times 0.2, that's just x, because this is the same thing as 1/5, and 1/5 times 5 is just 1. 0.2 times negative 8, that'll be negative 1.6. Now I can multiply all of that by 10. So I almost forgot to distribute that 0.2 first, so that's very important. Now when I multiply by 10, this just becomes 6. Well, that's nice, that's a whole number. This just becomes 13, that's great. This becomes 10x, that's a whole number, and this becomes 16. So I like this better because I no longer have any decimals. So what you're going to do is you're going to look and you're going to say, well, what can I multiply this by to get rid of the decimal? In this case, 10 worked because it got rid of all the decimals. That's why I wanted to choose 10. Now I can just follow my normal procedures. Okay. Now here's where I kind of do things a little different. I don't like to have to deal with negative numbers, so I'm going to subtract this 6x over. So this time I'm going to have my x on my right hand side. Either way is correct, okay? But this is going to keep me from having to deal with negative numbers, so I'm going to do it this way. So now I'm going to add my 16. I'm going to add my 16. 3 is equal to 4x. See how nice that is? There's no negative to have to deal with. Okay, I just kind of like to do it that way. Either way is mathematically correct. I think we're often taught that the x can only be on the left side when the x can be either on the left or the right side. Either way is mathematically correct at the end of the day. So now I'm going to look at this. I want to multiply by the LCD. So some of y'all might be able to look at that and say, that I know the LCD. Others may not, so you just make a list. 3 and then 6, 6 and then 12, 2 and then 4, and then 2 and then 6. So I see that my LCD, and hopefully this will highlight without highlighting the whole page. I see that my LCD is 6. So that lets me know that I can multiply this whole, and let's change the color because it's kind of sort of blending. It means I can multiply this entire thing by 6, and I'll no longer have fractions. So 6 times 2, that's 12 over 3. And I'll just write this intermediate step. Y'all don't have to, but I like for you all to be able to see what I'm doing. So I'm going to write my intermediate step. 6 times 5 is 30. 6 times negative 3 is negative 18. 6 times 1 is 6. And 6 times 5 is again 30. Now I'm just going to simplify these, okay? And some of you all can do that step, of course, in your head. I personally like to just show it to you all for the first time so that you know what you've done. So 12 divided by 3 is what? 4. 30 divided by 6 is 5. There's nothing to divide there. 6 divided by 2 is 3. And there's nothing to divide here. Okay? So this is kind of an intermediate step. Y'all might can do that in your mind. You might want to write it out. Okay, I just wrote it for the purposes of us being able to see that the first time. So now let's combine 4 minus 5, that's negative x, minus 18, and there's nothing to combine over here, so just bring those down. Again, I don't want to deal with negatives, so I'm going to add my x over. 3 x's plus an x is 4x. Going to add my 30. Add my 30. Okay, negative 18 plus 30 is 12. So I'm just going to kind of slide this up here. Sum of 12 is equal to 4x. We're going to divide by 4. X is equal to 3. Okay? And then I think what we're going to do is we're going to look at examples 6 and 8, and I'm going to leave example 7. So I'm trying to solve this for x, so that just means get the x by itself. Well, the first thing that's over here with that x is that minus 2a. I can bring it over to the 3a. Kind of looks like a Q. Sorry for that. And that gives me 5a. Okay. Now what am I still stuck with this 10, so I can divide that 10 over. So x is equal to, well, this will simplify, will it not? 5 will go into both of these, so 5 goes into 5 one time. That just leaves me with 1a, or you can just write it as a. Okay, the alternate version is to just write it as a. And then 10 divided by 5 is just 2. So your final answer is x is equal to a over 2. You can write it either way. You'll see it wrote in the homework, though, with just a and not a 1 in front of it, because we kind of assume that we know that the 1 is there. I'm trying to solve this for z, so I need to get rid of this fraction. You can do it all in one step. I recommend just getting rid of the fraction first, so multiplying by 2 on both sides, so then you're left with 2a is equal to 3 times z plus 1. Then what's still stuck there? The 3, so you divide by the 3. So now we have 2a over 3 is equal to z plus 1. Then we need to subtract the 1, so our final answer is 2a over 3 minus 1 is equal to z. I just recommend that first step of multiplying by the 2 and then dividing, because if you do it the other way, you have to remember how to divide fractions. And for some of us, it's been a long time since we've divided by fractions, but when we divide by fractions, we keep the denominator. Well, we keep the first fraction. We change from division to multiplication, and then we flip the denominator and the numerator. So it's a little bit more work than just multiplying to get rid of the fraction and then dividing in 2 separate steps. Ultimately up to you which approach you take to doing that. Okay, so now let me bring my mouse. Operations of functions. Let f and g be functions. So here's how we find the sum, the difference, the product, and the quotient of functions. The domain of the sum, difference, product, or quotient is the domain of f and the domain of g, and the domain of the combined result. Okay, so let's look at an example here to see that. So let f of x equal x squared plus 5x and g of x equal 2 divided by x minus 7. Evaluate the following functions. So this is basically saying I've got f of negative 3 plus g of negative 3. Okay. So first let's find f of negative 3. So f of negative 3 is going to be negative 3 squared plus 5 times negative 3. Negative 3 squared is 9. 5 times negative 3 is negative 15. 9 minus 15 is negative 6. Okay, so that's that. Now let's do g of negative 3. It's going to be 2 divided by negative 3 minus 7. Negative 3 and negative 7 make negative 10, so it's going to be 2 over negative 10. That's going to simplify to 1/5. Okay, so then we're just going to write that down. So f, so this was kind of step 1. Now we're going to do step 2. Oop. Took my line all the way over, and then I hate how it just wants to erase everything. Okay, so I'm going to have f of negative 3 plus g of negative 3 is equal to negative 6 plus negative 1/5. I've got to get a common denominator because this is just negative 6 over 1. Okay, so common denom equals 5. So I'm going to have to multiply this by 5. Negative 6 times 5 is negative 30. 5 times 1 is 5. Now I can add those together. What's that get me? Negative 30 plus negative 1 is negative 31 over 5. Or if I wanted to express it as a decimal, I could say it was 6.2. Okay. So you have to get that common denominator there. Alright. This one means to multiply, so this time I'm having f of 4 times g of 4. So we're going to follow that same step 1 where we rewrite f of 4 is equal to 4 squared plus 5 times 4. 4 times 4 is 16. 5 times 4 is 20. 16 plus 20 is 36. G of 4. 2 over 4 minus 7. 2 stays. 4 minus 7 is 3. That's negative 3. So that's negative 2/3. So then step 2 becomes rewriting this. So f of 4 times g of 4 is equal to those two numbers we found times each other. So to do it, 36 times negative 2/3 times negative 2/3. Now the nice thing about this is multiplication. You don't need a common denominator. You can just multiply across. So 36 times 2 is 72. Yep, because 30 times 2 is 60, and 6 times 2 is 12. 60 plus 12 is 72. So that's negative 72 over 3. And y'all will have to trust me with this because I forgot to bring up the calculator. But that gets you 24. Y'all can try that on your calculator and pause the video. Alright, so that's evaluating functions. Now let's look at a couple of domains. Okay, so first we're going to rewrite this. So this is going to be the square root of 2x minus 1 on top, because it says f is on top. X minus 9 is on the bottom. Okay, so let's find our domains. Well, we know that this has to be greater than or equal to 0. So let's go ahead and solve that. So let's add 1, because we have to find the domain of each, remember. So that's 2x. So x has to be greater than or equal to 1/2. Okay. Now remember, on the bottom of a complex fraction, or a fraction in general, you can never have 0. Okay, because you can't divide by 0. So we need to figure out what makes that divide by 0. In this case, 9, because 9 minus 9 is 0. That's not going to work. Okay, so x cannot be 9. So our domain would start at 1/2, because that's what we found for our top half. It can go to 9 with a parenthesis. It cannot include 9. But we can then go from 9 to infinity, because the only thing the bottom can't be is 9. Okay, So that's our complete domain. You kind of have to bring those two together. Okay. Now this next one's going to be just a little bit simpler. We have one less step because of the way it's wrote. So this time I've got x minus 9 on top, and I've got 2x minus 1 on bottom. The top can be anything. Okay, it could be anything. So basically, infinity really, okay. The top can be anything, because it can be 0 this time. So there's no step there, but we still have to know that the bottom has to be greater than 0, right? Because this cannot be 0. Okay, so we have 2x minus 1 is greater than 0. We're going to solve. 2x is greater than 1, divide 2. X has to be greater than 1/2. Okay, so that means the domain can be 1/2 to infinity. Okay. Why? Because this cannot be 0 on the bottom. Before, it didn't matter that it equaled 0. We just know that a square root function can't be negative in these cases. But this time it can equal 0 because we can't divide by 0. So this time it has to be a greater than in example B versus in example A, where it could equal 0, because you can have a 0 in the top of a fraction but not in the bottom. All right. Let's try us a couple more of these. So let's rewrite first. So this is going to be x minus 3, minus 2. Now remember, to subtract those fractions, we have to have a common denominator. The common denominator is going to be what these two are. What do I mean? I mean we're going to have to multiply by the opposite. And it may have helped if I'd switched colors here. So now these can be brought together. Okay, so let's kind of work that out, because it's all going to have the same bottom now, which is nice. So it's all going to have x minus 3 times x minus 5. And then I'm just going to do some distributing. X times x is x squared. X times negative 5 is negative 5x. 2 times x, that's a minus sign, so let's make sure we carry that. A negative 2x. But a negative 2 times a negative 3 makes a positive 6. Remember, this is a negative 2. Negative 2 times negative 3, positive 6. Okay. So now we can combine those like terms here. So this becomes x squared. 5 plus 2 is 7. Keep negative sign because they're both negative. We've still got that same denominator, that common denominator we made. Now I want to factor this because it's going to be easier to find the domain once I have it factored. Alright, so let's factor this out. What can I have that'll multiply to get me 6 but add to get me 7? Well, 1 times 6 will surely do it, but they both have to be negative, because a negative 1 times a negative 6 makes that positive 6, and a negative 1 plus negative 6 makes that negative 7 there. Alright, and that's kind of what we reviewed in the first 2 weeks. So x minus 1 times x minus 6 over x minus 3 times x minus 5. Okay, that's as simple as I can get that. Now let's work on that domain. Well, just like before, we know that this bottom of this fraction cannot equal 0, so let's figure out what's going to make it equal 0, and that's what we can't have. So I can't plug in a 3, and I can't plug in a 5. So that means I could have any number less than 3. That's what this is saying. Then I can have any number between 3 and 5. I can't have 5. Then I could have 5 and any number greater than 5. Okay, so that's kind of the word answer for what each of those meant. Okay? Because you can have anything but 3 or 5 in the domain, because that's what's going to make the bottom 0. The bottom can't be 0. It really doesn't matter what's up top, because it could be any number and it's going to work out fine. The only reason we had the restriction in the earlier ones is because the number inside of those square roots needs to be larger than 0. Okay? So now let's look at this. This is the reverse of what we had before. This time we're doing with division. So I've got 2 over x minus 5 and x minus 3. Now this is where that keep, change, flip option comes from. So 2, and then you change it from division multiplication, and then you flip-flop that second fraction to turn it to a multiplication problem. Okay? So keep, change, and flip. And this is where you change from division to multiplication. And you keep the first, and you flip the second fraction. Okay, I don't know if writing those extra notes there helped or not. So then let's multiply. So I've got 2 times x minus 3 and x times x minus 5. I just want the parentheses to be on the same side as why I flip-flopped those. So now we got to figure out what's going to make 0. So x minus 3 cannot equal 0. X minus 5 cannot equal 0. And x cannot equal 0. Okay, so we've got 3 conditions. So x cannot equal 3. X cannot equal 5, and we already know this one because this can't be 0, this can't be 0, and this can't be 0. Why? Because this one was originally in the bottom, and so was this one, so you have to also work this case. Because in the original problem, that x minus 3 is in the bottom, not in the top, so you need to know what's going to make it 0 as well. Okay? So we could have negative infinity to what? 0. Then we could have 0 to 3, not including 3. Then we could have 3 to 5, not including 3 or 5. And then not including 5 to infinity. So these 3 numbers cannot be x. Okay? So that's why we have to write that domain like that. Alright. Now let's find this and simplify it. Alright? So firstly we're going to write it out. F of x, 5x squared minus 7x minus 10 is f of x minus and then put some parentheses around it, what g of x is. G of x is 4x minus 10 divided by h of x, which is x. Okay. Now let's distribute this negative sign. So now I've got 5x squared minus 7x minus 10. Positive 4x times negative sign is negative 4x. Negative times a negative, that becomes positive 10. Okay, now let's combine these like terms. Let's combine these like terms here. This and this will add to 0, right? So I can just strike through those, really. My other like terms is negative 7 and negative 4. I can rewrite that. So that becomes 5x squared minus 11x over x, right? Because negative 10 and positive 10 it made 0, so I don't have to write that. Okay, now let's see, what can I take out of here? What's my GCF? My GCF of 5x squared minus 11x is x. So let's take out x. Well then, x divided by x is just 1. So I'm left with 5x minus 11. Okay. And of course, as always, I recommend pausing and rewinding as needed. Okie dokie, so this one's a lot of fractions, but we are going to make it through it together here. So I'm going to have 3 over x plus 8 minus 3 over x over 4. Now I want to get rid of this complex part of this just because I can visualize this better if I do. So I'm going to rewrite this like this. Because really that's just 1/4, right? Because there'd be a 1 in top and the 4 in the bottom, so we can do that. Okay, so I don't yet have my common denominator. Right, so I need to get that. And that's going to be just like we did earlier. Okay, so I'm going to rewrite that out here. So I'm going to have 3 times x over x plus 8 times x minus 3 times x plus 8 over x plus 8 times x. And that's to get that common denominator, and it's going to be times that 1/4. So I'm just going to rewrite this all over that new common denominator. Now, I don't know whether y'all want me to write it under here, y'all want me to move over here. I don't know what's going to be better for y'all, so I'm going to write it. So my common denominator is x times x plus 8 now. And this is going to be negative 3x, and 3 times 8, negative 24. And then 1/4 right now is just along for the ride. Now this, oh, and we were doing so well, weren't we? It was highlighting, no wonder. Oh, grand. Okay, so no highlighting, sadly, because it was doing so good, wasn't it? It was letting us highlight and everything, and now it said I don't want to do that. But a 3x and a negative 3x cancel. So then we've just got negative 24 over x times x plus 8 times that 1/4. And I'm going to move it over here. So I've got negative 24 times x plus 8 times that 1/4. Now we can distribute the 1/4, or we can say to ourselves, I know that 24 divided by 4 is 6. So I can simplify. So then negative 6 over x times x plus 8. If I know that negative 24 will divide by 4 and get me negative 6. That's kind of simpler, if you could call it that, than trying to distribute the 4. Either way, you're going to end up dividing that 4 out. This way you just do it instead of having to send it in the first place. Okay. Now let's look at some word problems. Kendall and Jason are opening a savings account together. Kendall will initially deposit $250 and then add $155 every month. That lets me know that this needs a variable because it's every month. Jason will not make an additional deposit, but we will add $395 every month to the savings account. Okay, so I'm writing two different equations. I got one for Kendall and one for Jason. Write the equation of the function that represents the amount Kendall deposits. Okay, it says it wants to be k of x, so I'm going to start that. Well, Kendall, it says he initially puts $250 in, and then he adds $155 every month. Okay, write the equation that represents Jason. Well, since Jason doesn't make an initial deposit, but that he puts $395x every month, okay? And x represents every month. Okay, x represents every month. Alright, now let t of x be the total amount deposited into the savings account by both Kendall and Jason based on the number of months x they have been saving. So this is telling me that the total is going to be whatever Kendall's function is plus Jason's function. So I'm going to write that down. Well, we know that Kendall is 155x plus that 250. And then we know that Jason is just 395x. And then if we want to simplify, let's see if the highlighter will sing. We know that, well, it sang for the first one, and then it said, I'm tired of singing. Okay, we know that we have to combine those, so 155 plus 395 plus 250 on the end. So I'm going to give y'all a second to add that. My calculator says that that's 550. Okay, so that's the combined function. Alright. Adobe Hope, a non-profit agency, publishes the weekly newsletter Community Options. The fixed cost for publishing the newsletter is $900 per week. Fixed cost lets me know that that is just how much it costs without anything else. With a variable cost, that lets me know it needs a variable of 25 cents per newsletter. Okay, so C of X, that's the cost. The newspaper is sold for $1.50x. Okay, X represents each copy. Okay, so if I want to find the profit, P of X, we're going to have to figure out how much we're charging minus how much it costs. Well, we're charging $1.50x, but it's costing us 25 cents per copy, plus $900 the fixed cost, probably the ink and paper and employee salaries, stuff like that. So let's simplify this up. Let's distribute that negative sign. And then I can combine, let's see if it wants to let us highlight or not. I can combine these two since they both have x. That'll leave me with $1.25x minus 900. So the profit function is 125x minus 900. Determine how many newsletters must be sold to break even. So breaking even is when the profit is 0. Okay, that's the break even point. Because you haven't made any money and you haven't lost any money. So let's solve our profit function for that. So first I'm going to get rid of the constant by adding it over. 900 is equal to 1.25x. Going to need to divide by 1.25 on both sides to get x by itself. X is going to equal 720 news letters. So they have to sell at least 720 newsletters before they've at least made $0 in profit. Determine the profit that will be returned if 1,000 newsletters are sold. P times 1,000 equals 1.25 times 1,000 minus 900. P of 1,000 equals 1250 minus 900, because you multiply that by 1,000. It's like moving the decimal 3 places. We're going to combine that, so the profit from selling 1,000 newsletters is $350. Alright, so now we'll move into slope. Slopes have many applications in everyday life. The following information about ramps is taken from the American with Disabilities Act ADA website. The rise of the ramp is the vertical dimension and the run of the ramp is the horizontal dimension. The maximum slope of a ramp in new construction is 1/12 with a maximum rise of 30 inches. What does it mean for the slope of the ramp to be 1/12? It means that for every 1 inch increase in the height the ramp must be 12 inches in length. If the ramp needs to have a height of 8 inches, how many inches must the length be? So I'm going to draw an imaginary ramp to look at here. So I've got 8 inches and 12 inches. If the ramp needs to have a height of 8 inches, how many inches must the length be? Okay, so we know that we need to rise for 12 inches. We need to figure out how high it has to be. So we know our ratio is 1/12, which is equal to 8 inches, but we don't know how long this ramp needs to be. So I can cross multiply. 8 times 12 is going to equal 1x. 8 times 12 is 96. 96 will equal to x. so 96 inches. Okay, the slope is the ratio of the vertical change or the rise to the horizontal change or the run. Okay, so here's the types of slopes. We can have an increasing line, which is a positive slope, a decreasing line, which is a negative slope, a horizontal line, which does not have a slope, and a vertical line, which has an undefined slope. Y equals mx plus b. M is your slope, b is your y-intercept, k is any real number. Our slope formula is given. Find the slope of a line passing through the given points, then classify. Each line is increasing, decreasing, horizontal, or vertical. Okay, so let's find the slope of these. This is x1. If that's x1, then this has to be y1. They have to match. If this is x2, then this is y2. We're going to plug it into our formula. Okay, so I have y2 minus y1 is my formula. So I'm going to have -5 minus 15, x2 minus x1. Two minuses make a plus. I always circle them. -5 minus 15 is -20. -3 plus 7 is 4. -20 divided by 4 is -5. It's negative, so it's a decreasing, meaning it's going down. Okay. x1, y1, x2, y2, and then I'll leave example 20 for you. I'm going to write it -2 minus a -2 over 1 minus a -6. We're circling our two minuses to note that they're pluses. That becomes 0 over 7. So that means the slope is 0. So that means it is a horizontal line. Now let me go ahead and do number 20 as well, because number 20 is a vertical line. 8 minus -5, circle those two minuses. 3 minus 3, that's 0, and remember we cannot divide by 0, so that means it's an undefined slope. When we have an undefined slope, we know that it is a vertical line that we are dealing with. Okay. Let's find the slope of the following line. On a graph, we're going to count between these dots. So I'm going to draw my little triangle. I had to go up 1, 2, 3. You count the lines in between, not your blank spaces. 1, 2, 3, 4. Remember that slope is rise over run. So the slope is 3/4. Okay. This one, I need to solve this so that it is in slope-intercept form, or y equals mx plus b. I want y by itself. The first thing that's keeping me from y is 2x. So I'm going to subtract it. I'm going to have 4y is equal to -2x minus 4. We want the x part in front, so that's why I'm writing it in front. Okay. You can rearrange them because of our properties of equality. We're going to divide by 4. 2 will go into both, leaving me with 1/2. And then I also have to divide 4 by 4, which is -1. So my slope where my m is negative 1/2. Just be reminded that this 4 has to divide both pieces, not just one piece. Okay. Slope of parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. So we're going to take a moment to see what that looks like here. We're going to determine the slope of a line parallel and perpendicular, if possible. Okay, so firstly we got to get this into that y equals mx plus b form. First step is to subtract 3x, so my 4y is equal to negative 3x plus 8. We're going to divide by 4. Remember, 4 divides both, so that means negative 3/4 x plus 2. Parallel has the same slope, so that means the slope for the parallel line will be 3/4. Opposite means that if it was negative, it becomes positive, so this perpendicular slope is going to be positive. And I'm going to take the reciprocal or flip. So flipping 3/4 becomes 4/3. Okay. Now this we know is a horizontal line because it's a y equals. So that means the slope is 0. So a parallel line would have a slope of 0, but a perpendicular line is undefined because you can't take the reciprocal of 0, so that would just be a vertical line. Okay. Now average rate of change is basically the same thing as slope. We're going to use the same formula. The concept of slope can be extended to functions as the average rate of change. The average rate of change of a function is the slope of the line, whether it be an exponential function or a linear function. Find the average rate of change of the following. So these are my x1 and x2 values, as it were. I'm going to substitute those in to find my y values. Negative 1 to the third is just negative 1. Negative 1 minus 8 is negative 9. Plugging in 3, I'm going to have 3 to the third minus 8. 3 times 3 is 9. 9 times 3 is 27. 27 minus 8 is 19. So now I'm going to write my ordered pairs. I'm like negative 1 and 9, and 3 and 19. I'm going to label it x1, y1, x2, y2, 19 minus 9 over 3 minus a negative 1. Circle my minuses, turn them to plus. 19 minus 9 is 10. Oh, that's a negative 9. That's a oopsie daisy on my end. And then we'll circle, so it's 28. That negative sign snuck up on me. 28 over 4, which is 7. So my m is 7. The table represents the cost of a U.S. postal stamp as a function of the year. Find and interpret the average rate of change between 2016 and 2010. Okay, so I'm going to find those on my graph, well, on my table. 2016 and 2010. Okay, so 2016 is going to be x2, y2. 2010 is going to be x1 and y1. So I'm going to do 0.44. Well, we're going to do it. I'm trying to do it backwards. 0.44 0.47 minus 0.44, and then 2016 minus 2010. That leaves what, 6 and 0.03, right? Because that's the difference there. And then I divide that. I'll pause for a second and give you all the chance with your calculator. But that's 0.005. So stamps increased an average of 0.005 per year between 2010 and 2016. Find and interpret the average rate of change between 2013 and 2015. So let me get a different color so that we can circle 2013 and 2015. So that'll be x2, y2, x1, and y1. So I'm going to have 0.49 minus 0.46 over 2015 minus 2013. That's a difference of 0.03 and a difference of 2. Okay, and that gets me 0.015. So stamps increased on average of 0.015 cent. So about 2 cents per year between 2013 and 2015. Of the two intervals, which one had the greatest increase in cost? Well, the increase in cost was the same, right? 3 cents over each interval. So both intervals have the same increase in cost, which is 0.03 cents. Of the two intervals, which one had a greater increase? Well, this was what? 0.005, so about less than a penny, right? And then this one had 0.01, so this one's greater, right? So we could write that up. So we can write the interval from 2013 to 2015 had a greater increase in cost per year, and we can write that 0.015 is greater than 0.005, because this would round to just 0.01 and that would round to 0.02. Do we have a is this relationship linear? No, it's not linear. Why? We do not have a constant rate of change. Slope in cost per year. If it was linear, the change would have been the same, between 2013 and 2015 and 2010 and 2016. But it's not. Okay, so we know that it's not linear. Okay. Your friend goes hiking up the tallest mountain in North Carolina, Mount Mitchell, and wants to know if there is a relationship between air temperature and altitude. She records the following data. Is this a linear relationship that defines temperature as a function of altitude? Why or why not? Well, let's look. I went up, what, 1,000? Right? And that's a difference of what? 4 degrees. So we can say yes, there is of 0.004 per foot, or negative 4 degrees per 1,000 feet, as we see in the table. So yes, there is a constant average rate of change of negative 4 degrees Fahrenheit per 1,000 feet. What does the average rate of change mean in the context of this problem? Well, we can find it. We can actually find it, and I think that might be looking a little better if we do that, to actually find it and interpret it in terms of feet, right? In terms of per foot, instead of having it the way I've got it up here. Okay, we know it's linear because we've compared it on the table, but let's actually find it per foot. And that's going to be negative 0.004 degrees Fahrenheit in our calculator. So temperature decreases an average of 0.004 degrees Fahrenheit per foot traveling up the mountain. And if we found the slope between these 2 points, we would find that that's also negative 0.004. Okay, I'm not going to put you all through having to watch me do that, because this video is already a little long. So the difference quotient. Let P be the point x comma f of x on the function f. Let Q be the point x plus h, f of x plus h, where h is a positive real number. The average rate of change between P and Q is called the difference quotient of the function f at x, as shown. The difference quotient is important for calculus in defining the derivative as the instantaneous rate of change of a function. Okay, so we got two examples, and we'll be finished. So let's work through then. Okay, that was a lot of words at once. Let's work it through it together and see how we go. Okay, let me change out that green. That green is not my favoriteest color on here. Okay, x plus h minus f of x. So I'm just copying down the formula from up here. Okay, that's all I've done. And then we're going to plug it in. Okay, so we're going to write that in. So it's going to be 2 times x plus h squared, because anywhere we see x, we're replacing it with x plus h, minus 3 times x plus h plus 1 and then we're going to minus it by just the function without plugging anything in. And then the bottom is just h. Okay. So now let's kind of work through this here, as it were. So I am going to do this x plus h with FOIL. So x squared plus xh plus xh plus h squared, and then that just becomes 2xh's plus h squared. I hope I didn't do that too fast. Y'all let me know, and the next video won't be as quick. So we're just going to fill that in. Plus 1 okay, so that looks fine, but then we've got to distribute for this part. So then we're going to have minus 3x minus 3h. That plus 1 doesn't go there. Plus 1. I was going to leave that part off. That would have been an oopsie daisy. So now let's distribute that negative. So that's going to be negative 2x squared plus 3x minus 1. And we should see that this works out nicely for simplification purposes. Now let me change my pen. So we're going to multiply. So that becomes 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1. Okay, it's just a lot of carrying it down. It's kind of what we got to do. Now we're going to play match up. This 2x squared will match up with a negative 2x squared and be eliminated. This negative 3x will match up with a positive 3x and get eliminated. This positive 1 will match up with a negative 1 and get eliminated. So now let's change back to our pen. So then I'm left with 4xh plus 2h squared minus 3h over h. Okay, so I hope y'all are following so far. I hope me doing this part up here where I showed y'all to FOIL that helped. Okay, so now I'm going to factor what's common. H, H, and H. Let's take out H. So this is 4x plus 2h minus 3 over h. So that GCF, so take out GCF of h. And I know that at first it's kind of, you don't really think about taking out letters as a GCF. Okay? And I think this video is probably long enough and y'all are ready to see Miss Church just go away for a little while until next week. So I'm going to leave the last one up to you all. So I thank you all for your time and for listening to me teach. As always, I'm only one Canvas inbox message away from helping you. Thank you.